To continue, let us read the following in thermodynamics and its processes. Thermodynamics is the study of heat and its transformation into mechanical energy. The thermodynamics stems from the Greek word meaning movement of heat. The science of thermodynamics was developed in the mid 1800s, before the atomic and molecular nature of matter was understood. Apparently, mechanical work, pressure, and temperature play important role in energy transformation. So, the foundation of thermodynamics is conservation of energy, a topic that is not actually foreign to you. This add the fact that heat flows from heat to cold provide the basic theory of heat engines, from the steam turbines to fusion reactors, and the basic theory of refrigerators and heat pumps. To begin our study of thermodynamics, let us consider the different processes that may be involved in a thermodynamic system. Okay, what is a thermodynamic process? Okay, it is a change of state that can be described as any change in the value of the following quantities. So it includes pressure, volume, temperature, and quantity of a substance. These quantity are known as state variables. The variables that we have mentioned and used during the use of the work formula. State variables are variables that describe the features of a system that are always the same whenever that system is in a given state. A state is a particular situation wherein a system has a specified values of pressure, volume, temperature, and quantity of a substance. If the process can be made to go in the reverse direction, it is called a reversible process. So, pwede ma-reverse. Otherwise, it is an irreversible process. So there are processes in thermodynamics that cannot be reversed. A cycle is a succession of changes that ends with the return of the system to its initial state. In the course of the discussion, the first thermodynamic process which will be deal with is a constant volume processor known as isovolumetric or isochoric process. A sealed car left this one under the sun will cause the temperature to rise. The rise on the car's temperature also indicates an increase in the internal energy inside the car. But because cars are made up of sturdy and strong metal, any change in the volume of the car is negligible. In general, under a constant volume process, no work is produced by the trapped gases in the car. The heat absorbed by the car is used to increase the internal energy, so no work is done by any gas that receives heat and undergoes as isovolumetric process. The second thermodynamic process is a constant temperature process or an isothermal process. A system undergoing an isothermal process absorbs heat, but the temperature remains constant. An example of an isothermal process is the boiling of water. When water is heated to 100 degrees Celsius, it will not start boiling instantly. It will keep on absorbing heat at constant temperature. This heat is called the latent heat of vaporization. In isothermal process, the heat received by any system is converted to work. The next thermodynamic process is when the heat content of the system or certain quantity of matter remains constant. This process is called an adiabatic process. An adiabatic process involves no transfer of heat between the system and its surroundings. The walls of the system which does not allow the flow of heat is called diathermic wall. A diabatic process happens when there is a rapid decrease in pressure that the system has limited time to absorb heat from the surroundings. The work done in a diabatic process will cause the temperature of the system to decrease. The decrease in internal energy is equal to the energy that the gas needs in order to perform work. So, let's ask this question. How do adiabatic processes occur in the atmosphere, oceans, and Earth's mantle? Okay, let's read the last paragraph. The last thermodynamic process in the constant pressure process known as the isobaric process. An example is a fuel cylinder and a movable piston arrangement. When this fuel is combusted or ignited, pressure due to the burnt gases is generated inside the engine. As more fuel is burnt, the greater pressure is created. Since the piston is movable, the gases are allowed to expand freely. The pressure of the system can be kept constant. Due to the burning of the temperature of the system increases, thus the internal energy of the engine also increases. In the given example, the heat absorbed is equivalent to the work done by the expanding gas and sum to increase the internal energy of the system. So we are now ready to answer our apply the concepts number one, and number two.